Hello, physics. Very interesting question. The question says that the object of mass m2 hanging by a string. A bullet of mass m1 hits horizontally, and there are three cases A, B, and C. A, bullet hits m2 and pierces and continue its motion. Bullet gets stuck and bullet recoils. So in first one is a bullet pierces, two is stuck, and three recoil. In which case the object, the m2, is deflected by the largest and smallest amount or mean velocity, in which case velocity is higher. Answer. We will apply the conservation of kinetic energy and conservation of linear momentum. So this is a bullet. This is m2. This is m1. This is hanging, and it looked like this one, m1 bullet, and this is m2, and then afterward m2 have a different velocity and m1 has a different velocity. So conservation of linear momentum, so this will be m1 before and this one is after. So m1, this one, v naught initial momentum is equal to the final momentum of m1 u1 and final momentum of the object m2 u2. So initial bullet velocity, final bullet velocity, and the final object velocity. So if you rearrange this one, then we will be able to get this one on the other side. That will be on other side. m1 is common, so v naught minus u1 over m2. So this is the velocity of the object. Case 1. Bullet pierced through the object. So if it is pierced through the object, then the final velocity will be also this will be that the part of m2 object plus small amount, another amount of velocity. So v naught v. So we will write down as v u1 is equal to u2 plus v. So in equation 1, if you substitute this u2 here, in equation 1 is this one. This is equation 1. And this is in the case of flies and pears. So u1 is equal to the final velocity of the bullet will be composition of the velocity of the object plus some other velocity which is going through. So that will, if you put this value in this one, so m1 v naught is equal to m1 u2 plus v plus m2. So this one. So these u2 and u2 and this equation will go on other side. So m1 v and minus v is equal to u2 m1 plus m2. From this equation you will get v2 or u2, the object velocity, which is equal to m1 into v naught minus v over m1 plus m2. This is equation number 3. Next case, bullet stucks. When a bullet stucks, is velocity, the bullet uh, final velocity is the equal to the object velocity. So, and this one is equal to, if you put this one in here, so that means v is equal to 0. If v is equal to 0, then we can have this equation. V is equal to equation 3 will be modified to equation number 4. Equation number 4. So we have equation number 4 for the case B. Now next case Case C, the bullet recoils. The velocity it acquires after the recoil is u1 is negative. If it is negative, then equation number 2, you will put this one, equation number 2, this one. So it will, if you put this one u2 negative, 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 positive, then this is equation number 5. So uh, case A, when the bullet pierces through the object. Case B, when the bullet stuck in the object. Case C, when the bullet recoils. So this is equation number 3. This is 4 and this is 5. So this is 3, this is 4, this is 5. So also M2, the object is very large compared to bullet mass. So if you look at this one, so maximum velocity, the velocity of the object, highest to lowest, highest will be recoil, and the lowest will be in pairs, where the bullets have still more velocity. And in the middle, when it's stuck, the object will get the smallest velocity. So these are the three cases. The velocity of the object, highest to lowest. So a recoil will be the highest, lowest will be the pairs, and the middle one will be in when it is stuck.